These questions deal with motion, and again, it's up to you whether or not you choose to use the table. I'm going to show you how to use the table in this next question. So here I'm dealing with a hiker that's hiking faster downhill, of course, than she is hiking uphill. And I know that whenever I'm dealing with motion, quite often uniform motion anyway, I'm using distance equals rate times time. So distance equals rate times time. So it might be helpful for you to make a table to help you with that. In this case, again, we always want to use our variable to equal to what we're trying to solve for. So in this case, x is the speed hiking back to the campsite. So that would be the uphill version, would be my rate. So rate and speed, of course, are the same thing. What else do I know about rate? I know that the hiker can hike 1 mile per hour faster downhill. So if the rate uphill is x, the rate downhill is 1 mile per hour faster. What else do I know? I don't know anything about distance so far, but I do know that the time is 3 hours to the lake and is 4.5 hours to the campsite. I don't know the distance, but what I do know about distance is that the distance is the same. So of course, if I'm hiking from the bottom of the hill to the top and then from the top down to the bottom, that's the same distance either way. So what I'm going to do is I'm going to use this rate times time to find the distance, which is of course 3 times x plus 1 and 4.5 times x. Those are the two distances, and I know that those are the same. So I'm just going to set this distance equal to this distance because it's the same distance up and down the hill. And then solve, which should be pretty simple. 3x plus 3 equals 4.5x. 3 equals 1.5x, and then 2 equals x. So what does x tell me? X is the rate uphill to the campsite. So my rate to the campsite is 2 miles per hour. And then of course coming back would be 2 plus 1, which is 3, or 3 miles per hour. If you're not sure, you can of course plug in the value. So if I took 2 and plugged it in for x, that would give me 4.5 times 2, or 9. And again, take 2 and plug it in for x here. 2 plus 1 is 3 times 3, which is 9. So x does make sense. One for you to try. Press pause, do the question, then press play to check your work. So in this case, you and your roommate are leaving home at 7 a.m., heading in opposite directions for work. So far, nothing I can put here in the table. You usually spend 30 minutes biking to work. So you time 0.5 of an hour. Your roommate needs 20 minutes to walk to work. So their time is 20 over 60, or 1/3 of an hour. I don't want to write that as 0.33. The average speed is 7 miles per hour slower than your average speed. And so I'm going to say that my average speed is x, and my roommate's average speed is 7 miles per hour slower, so x minus 7. We work 6 miles apart. So this one is not going to be the same as the last one, but I am going to start it in the same way as the last one. I'm going to multiply 0.5 times x, which is 0.5x. I'm going to multiply 1/3 times x minus 7. And I know that instead of setting those equal, because we don't live the same distance from our jobs, but we do know that our jobs are 6 miles apart, which means my distance and my roommate's distance equals 6. So then from here, I'm just going to solve. Might be easier to multiply everything times 3 so that I don't have to deal with this situation. So if I took this times 3, it would be 1.5. This times 3 just gives me the x minus 7. This times 3 gives me 18. I'll add those two together to get 2.5x. Add the 7 to each side, which gives me 25. by dividing by 2.5, I of course would get that x is 10. So what does that tell me? That tells me that my rate, which is biking, is 10 miles per hour, and my roommate, who is walking to work, is going at 3 miles per hour.